Hey everyone, this is Mr. Warwick. I'm going to be going through these notes with you just real quick today. So this is 3.5, defining congruence and similarity through transformation. So right off the bat, that second slide says congruency. How can you tell if two shapes are congruent? And you discuss it with your table. Those first two triangles, they appear to be congruent. The second two triangles do not appear to be congruent. Congruency comes from a couple things. First off, you need to make sure that you have all of the angles exactly the same. And the next thing that you need to make sure that you have is all of the sides need to be the same. Now, there are some shortcuts, some things that we'll talk about what you exactly need to prove that triangles are congruent or that shapes in general are congruent, but that's what we're working with. The sides need to be the same. The angles need to be the same. So then on the third slide, it says which blobs are congruent and how can you tell? So there are some. If you pause it and try to figure it out, and then you can compare your list to my list. Okay? All right, coming back from what hopefully was your pause, and you're not just cheating your way through this. A and G should be congruent. B, I believe, is congruent with L. It may also be congruent with C. If you can kind of overlay them, that's how you can tell best. D is going to be congruent with either E, F, or I, and it's a way of you kind of putting them together. And H should be congruent with J. Now, the way that you can tell as we go to the fourth slide here, if it says the things that you need to know about congruence with transformations. A rigid motion transformation is a sequence of translations, rotations, or reflections, and two figures are congruent if and only if a rigid motion transformation can map one figure so it coincides with the other. So basically the stuff that we have been doing to say, I'm going to move this shape on top of this other shape, if it fits perfectly on top of that other shape, then they are congruent shapes. If it does not fit perfectly, then they are not congruent. The next slide, slide number 5, similarity. How can we tell if two shapes are similar as opposed to congruent? And what transformation have we done that would create similar shapes? We talked about similar triangles before, and the same thing applies to the other shapes. If all of the angles are exactly the same and the sides are in proportion to one another, then that's how we can tell that they are similar. They're not going to be congruent. Congruent shapes have all the angles the same as well, but the sides have to be exact. With similarity, they are half the size, they are twice the size, they are 3 times the size. So we have some kind of scale factor, which means the transformation that we have done that makes similar shapes is dilation, which we did yesterday. So 2 things we need to know for this one. A similarity transformation is a sequence of translations, rotations, reflections, and or dilations. So we put the dilations in there. That's really what's going to make it similar. And then 2 figures are similar if and only if a similarity transformation can map one figure so it coincides with the other. So if we rotate this to where all of the angles are going to match up and then we double it in size, that's how we can tell that these things are going to be similar. So hopefully that kind of takes you through on today's assignment. The compasses are there. You can use those to measure the sides, measure the angles, and just go through it meticulously and see if everything is going to be congruent, similar, and be able to say kind of why, not just yes or no. Okay, so make sure to put some measures on there, and we'll go over this real quick on Monday when I come back. Have a great weekend.